hence ultimately the production of OPC per se is not a sustainable activity if we are continuously doing this. And over a period of time, we know in each country the limestone reserves get exhausted, and hence we are getting into problems. So we need to have a control on the optimum content, and then we have to have strike a level where for what grade, how much we have to use cement content. And we also know that in the entire concrete, if you see, the only material which is synthetic is cement, other metals are natural metals, and every synthetic product, based on how it is processed and how it is made, has a tendency to go back to its natural state. So cement in the concrete has a tendency to go back to its natural state, which is limestone. And hence, we need to control the amount of cement content and make an optimum mixture. So to make the optimum mixture, we need chemical admixtures. That is how the origin of admixtures took place. So a definition is up to 5% you can add, which is a material which is other than fiber reinforcement, other than water and aggregates and hydraulic cement, which can be added, which changes the fresh and hardened properties of concrete, which modifies the properties of concrete, betters the properties of concrete. And if, as I said, betters the properties of concrete if we use it in a proper way. So we know admixtures can be used in a certain dosage. Generally, the dosages here is between 0.6 to 1.5, 2%. And we have different bases for these admixtures. The base of these admixtures, one of the bases which we are going to talk is lignosulfonate based admixtures, which we came first. And I just introduce the brief history of admixtures before we go into the latest, some of the latest things that we have here. So we can see here,
the filling station
200 years back, we got this
already shown.
Portland
So
cement,
if in case it
and then
requirements, we can also again we will show
admixtures
it.
came,
So
air intake
at the
admixtures
end,
came, and by 1955, plasticizers became commodities. 66 supers came into existence based on melamine, formaldehyde. 86, the Japanese scientist, when he was making an attempt to make high performance concrete, started using these polycarboxylates. Then we got polyacrylates, polycarboxylates, and then the latest base, which has almost changed the way the concrete is done, and not only in India, elsewhere around the world. This PCE based admixture came into existence.
you are attending the
So
class now.
if we
What class?
see period from 2000 onwards, the entire concrete, the way it is done, produced and transported and finished, has completely changed. So, as I said earlier, lignosulfonates, which is from paper industry, paper pulp industry, basically from wood, came into existence. Water reduction approximately 10%, and then the sulfonated naphthalene formaldehyde and melamine formaldehyde and all came, and most of the ready-mix manufacturers and most of the concrete producers, even though they don't bother about this information which is depicted here, and just they will take a cement content, particular cement content, just add a particular dosage of admixture, and then produce the concrete, and see whether the slump retained for 2 hours or 1.5 hours or 3 hours. Basically, in 3 ways, admixtures can be used. One, at the same water cement ratio, same mix design, you can add and get the increase. Then if you reduce the water cement ratio with the same cement content, you can get an increased strength. And then if we keep the same cement content as similar water cement ratio and get the same slump, you have a cement reduction, which is an economic mix design. So the shift which has happened, earlier a 400 kg mix was said to be 1.5, 3, which is M25 concrete, and this was supplied in specified in many books, concrete technology books, and even many specifications were talking of 8-bag mix and 6-bag mix like this. Now, with the advancement this with the concrete technologies, we are making the same M25 at around 300 to 320 kgs, almost 80 kgs of cement reduction, and hence 80 to 100 kgs of means whatever the carbon dioxide emitted is reduced. So that is how the technology has moved in the last, say, from 1990 to 2023. And uh, these admixtures, when we are shifting from so these admixtures, when we are shifting from one admixture to another, it has also facilitated mm, different materials usage, like usage of fly ash GGBS, usage of manufactured sand from natural sand. All these shifts have taken place. So other reasons why we have to use admixtures: reduce the cost of concrete construction, achieve properties in concrete more effectively than other means, ensure quality during stages of mixing, transporting, etc., overcome certain emergencies during concrete operations. So these are some of the other functions which admixtures can do. Just a list of the types of admixture as per ASTM 494. And we are talking about the shift from earlier, it was the popular use was ASTM C494 type D admixture, basically based on rignosulfonate based admixture. RP264 from POSRAP was one of the continuously used admixtures in the 1990s up till 95. And then started using type G admixture. Now, type G admixture, people have settled with type G admixture, which is a high range water reducing and retarding admixture throughout India in most of the companies. So, water reducing capacity, when the material shifted from one material to another material. You can see here the latest admixtures, which is polycarboxylic ethers, have gone up to 40%. Earlier, you know, water cement ratios below zero point 0.3 or 0.32 or 0.33 was difficult to make actually. Now it is easy to produce concretes with a water cement ratio of 0.25, 0.26, and something like 0.22 also, because of the enhanced water reducing capacities of these admixtures. Uh, Even though air and admixture is not a new technology, but when the
Recording in
human
progress.
beings or human beings touching moon in 1969. So it was a big leap. It was said to be a big leap in the concrete technology when these micro bubbles of air was introduced by these admixtures, which facilitate better cohesion, gives freeze-thaw resistance, which is very, very important in the cold climates. So air intrinsic admixture is I can say, one of the marvelous improvement which happened in the field of concrete technology way back, and it has been used and being used in most of the cold country climates. You can see air entrained and non-air entrained concrete. As we say, when we are using an air intrinsic admixture, earlier, even in India, many of the projects, even though it is not in the cold zone, they were using air intrinsic admixture. They have used air intrinsic admixture to make cohesive mix when sands were not good, when sands were harsh, sands were having very, I meant to say, unsized particles, ungraded particles to reduce the bleeding and make a cohesive mix, especially in dam sites where you are using big aggregates, 40, 80, 150 mm, depending upon where they're using. So you need to have, in those cases, a mix which is not going to segregate, which can be easily placed in those areas, in those situations. They used to use even in India, not because of the freeze-thaw resistance, but for making a better mix. And then came the biggest shift in the concrete technology itself when the Japanese scientists started making this called SCC, self-compacting concrete, where he was actually trying to make a high-performance concrete. So the SCC as a mix, which has more fines and less coarse aggregates, and generally now we have 12 mm down more rather than 20 mm down. Being earlier until 2010, you can say until 2010, the mixed design of an SCC was difficult. Now, thanks to the new admixtures which have come after 2010, huge improvements have taken place in this admixture technology, where you can make self-compacting concrete very easily. Basically, because the admixtures, which are also called as hyperplasticizer, which come with huge amount of water reduction capacity, have built-in viscosity modifying admixtures. So you can see a very smooth, cohesive mix without much bleeding, which satisfies all the properties of self-compacting concrete. You can say you can take flow test, YouTube test, L box test, V funnel test. All these tests it passes easily. And most importantly, earlier, I'm talking about until 2010, 2015. Um, when an admixture, especially admixture, is used SCC for making SCC, there used to be bleeding initially, and we need to wait for about half an hour or 45 minutes, or some cases until 1 hour, more than 1 hour, for the bleeding to come down. So it was in a way suitable for transportation for long distances up to maybe 2 hours. But now, what happens if the site is very close by? If the site is very close by, I cannot produce an SCC and sell them or transport them quickly if it is the 15 minutes or 20 minutes time. So there was a need for making a bleed-free admixture. The bleeding should stop within 10 minutes or 5 minutes or 15 minutes maximum. So now with modern VMAs, uh, very thick, cohesive mix without segregation has come into picture, and it is easy to was there earlier was stickiness in the concrete mix. Mix used to stick to the uh, concrete pump, concrete mixer wherever and it used to settle down. That kind of property was there. Now, thanks to these modifications, work has been done, and using different additives and chemicals, they have been able to give a cohesive, non-sticky, non-bleed mix from the beginning, which is easily pumpable and which can be transported and placed for 2 hours, 3 hours, something like that. So these viscosity modifying admixtures have been earlier. There was a situation until 2010 that these VMAs were supplied separately. You use this PC-based hyperplasticizers having a water reduction of about 40% separately as a component A, and component B you use as a viscosity modifying agent. Now, most of the admixture companies have started making built-in system where the VMA has been blended into the admixture itself, and hence it can be used for making high performance, ultra high performance pumped concrete wherever the concrete is required, wherever SCC is required. Reduced viscosity of concretes optimized towards a low environmental impact and high durability, and employs a very low water cement ratio. That is the key actually. So these admixtures have become an engine, I can say, for making these self-compacting concretes, which have slowly the percentage of self-compacting concrete is moving up, and probably one day we see everywhere self-compacting concrete only. So one of the latest things which has happened, which is very interesting, is like say for example, what happens if somebody wants very high slump retention, especially to have high-rise buildings where you need to have high retention because sometimes pumps may give a problem, pump may choke for some reason or the other, or somebody is unprepared for is means for all these things. Uh, some of the admixture companies have come up with high retention versions, actually high retention versions, uh, which can give a slump retention of almost 6 to 7 hours retention without causing any problem. Means especially I'm talking about no bleeding, no segregation at any point of time. You can place the concrete from 1 hour to 7 hours, it will be almost in the similar state. I mean to say, this lump will be easily pumpable, transportable, and then finishable. So some of these admixtures have a water reduction capacity of 50%, which is mind-blowing number. 50% water reduction is a huge number, and that kind of materials have come into the market, which is a huge shift in the way the admixtures are produced, which trigger different um, higher versions of concrete. So one of the mixes which we did recently is, we can see as an example, um, slump is collapse up to 6 hours, and 7 hours slump is also almost collapse. Is very huge high flow concrete, and you can see with a admixture dosage of 1.4%. And of course, I will come back to that when we used a product called iCrete, and we got this very good strength, we can see. So these things were unheard of earlier. It is very, very difficult probably to imagine a 7 hour slump retention earlier days. In fact, many of the concrete technologies were resisting this move because if somebody gives a retention of 7 hours, there can be tampering of concrete. Concrete can be tampered. Concrete, somebody can pour water into the concrete, misuse the concrete, abuse the concrete. But the requirements in the modern day, where high-rise buildings have come up, uh, different situations have come up. So we need to move to such admixtures where we talk about huge, very long slump retention. So the other technology which was there and which is being used in some places, especially in tunneling, and especially in other countries where you make the concrete, and if by chance it is not used, you put the concrete to sleep, and then you reactivate next day or whenever you want, maybe after 24 hours or 30 hours. Especially in tunnelings, it is used, and also many companies abroad, ready-mix companies, are using such technology for using a kind of a unused concrete or a rejected concrete or a concrete which has to be downgraded. For example, we send the concrete for some purpose, the customer does not accept for some reason, so you have to downgrade it, and it takes some time for all this process. So you keep the concrete sleep for some time. I mean to say dormant for some time and then reactivate it later. So this is also available, but not used in India. Maybe in tunneling it is used, but not in regular other concrete operations. So these Latest superplasticists have made life of concrete technologies and the concrete producer much better, much easier. So we can today talk of high performance concrete, ultra high performance concrete, self compacting concrete, free flow concrete, um, all easily placeable, transportable for 3 hours, 4 hours, 5 hours in traffic situations, and then we can use these admixtures for huge water reduction, and hence can produce high strength concretes. One of the good things that have happened, um, even though the shrinkage reducing admixtures came into existence long back in Japan, 1982, they were not very popular everywhere. Many of the customers I had seen in countries actually. So in recent years, these admixtures with which have the capacity to reduce drying shrinkage have been introduced in many industries, including precast pre-stressed concrete industries, and uh, especially popular in United States and elsewhere. And they they reduce the I cannot say eliminate. They reduce significantly the shrinkage. So these admixtures have also become popular in ready-mix companies, even in India, where some of the companies have started using this for roof slab, where customers want to eliminate, but elimination is not possible, or can significantly reduce the plastic shrinkage cracks and long-term shrinkage cracks by using this kind of admixtures. So the data show that the shrinkage reducing admixture used integrally or as a topical application will effectively reduce drying shrinkage of concrete and subsequently cracking. Because of its effectiveness, it has been used worldwide since 1983. And one of the big applications of this is to produce jointless floors, big floors, where uh, you can use this admixture, generally used at about 1 to 1.25% by weight of cement or cementitious content, where you have the probability of reducing the cracks to a great extent. Corrosion inhibitors also uh, is a big shift. We can say a paradigm shift in the concrete technology, where the RCC structures have to be protected for long term. You know, uh, we are struggling to construct buildings, high rise, medium rise, and general residential buildings for 75 to 100 years design life. Um, Basically, because of this RCC structures, where the steel is has a tendency to corrode in the presence of oxygen and moisture, and the concrete, if it has pores, capillary pores are more, sulfates and fluorides can get in and further deteriorate the concrete and deteriorate the RCC structure itself. So corrosion is a major problem, because of which the service life of any structure is under question mark. So where the ancestors, like the builders of Egyptian pyramids, whoever they were building structures to pass the test of time for about 5,000 years. We struggle to make structures which can stand the test of time for about 75 100 years, in spite of the big advancements which is happening in the last 200 years after Joseph Asford found the cement or invented cement. So when we are talking about the latest technology, still we are nowhere in the picture when compared to the ancient technologies which were available. uh, I can say it is a very kind of a irony that we talk of the latest technologies, but our structures are not durable for very long period, more than 7,500 years. Maintenance of structures is becoming a big business for many people, and maintenance and repairs is a huge loss to any nation. If you are spending a lot of money on repairs and maintenance, so it is a big cost for any company, any country for that matter. So in that respect, invention of calcium nitrate based or any other product which reduces the corrosion to a great extent is a welcome sign. Calcium nitrate based mixtures corrosion inhibitors have been used for a long time, especially it started coming in US. And in US, this lot of data is available for DCI from WRAs, a very popular product, both used in US and Gulf countries. And then the next shift took place where we are talking about migrating corrosion inhibitors. These admixtures can be integrally mixed uh, or can be surface applied, and these corrosion inhibitors penetrate into the concrete and make a layer around the reinforcement bar and then protect the embedded steel bars. So MCIs have become very popular, and now in India, in many of the major projects, especially infrastructure projects, MCAs have been specified and they're picking up. And in most of the, I can say, uh, many of the NHA projects and many of the projects like important structures like flyovers and all, people have started specifying MCIs. Migrating inhibitors play a significant role in the repair and rehabilitation of damaged structures also. Migrating or surface applied inhibitors are found to be cost-effective treatment for field implementation due to the ease of application. For this type of application, penetrating type amine carboxylic based inhibitors are preferable. The surface applied inhibitors can penetrate up to the depth of embedded steel reinforcement, thus adequate concentrations are necessary to provide corrosion protection. So uh, is a very happy solution for many of the situations where, especially in coastal regions, where the chlorine resistance RCPT values have to be improved, and then you have to protect the concrete along with SCM's good admixture. If we use integrally this kind of product, it significantly improves the longevity of the RCC structure. A lot of work has been done, especially in some of the universities of US, where super hydrophobic admixtures are being made. So they are trying to imitate the concrete surface, which they're making it. It should be something similar to a lotus leaf. Means once water falls, it should repel in such a way that no water stands on the concrete, no water goes inside. So that kind of super hydrophobic admixtures are being formulated and used, especially in case of where you require high um, abrasion resistance and high impermeability and durability is required. Other admixtures which are may not be significantly increasing the durability, but different applications. Other admixtures came into picture, surface retarding admixtures, where you apply uh, this material on the rubber mold or the molds, and then once the concrete is done, this admixture affects the setting time of the surface of the concrete, and once it will not allow the concrete to set on the surface, and then you come tomorrow morning, next day morning, and then splash with water, with a jet of water, remove the cement particles, and you get exposed surface. Home producing admixtures are used for making concrete which can fill uh, trenches, which can also act like a bed for uh, tiles or some laments. Now, other shift which has happened, or I can say other improvement in the technology side has happened, is admixtures which have um, come into market based on crystalline technology. So these admixtures interact with the cement hydration products, and then grow as crystals in the capillary pores and prevent water to get into the capillary pores and reduce the permeability of uh, concrete, and hence impermeability is significantly enhanced actually. So crystalline waterproofing admixtures have been used not only in other countries but in India, many of the structures, and its benefits have been reaped by many of the construction companies. You can see the microscopic view how the crystals are developed in a capillary due to the usage of crystalline waterproofing compound. Another microscopic view. As a as days are passing, we don't have much water left for usage by human beings, and where we are digging boreholes deep into the earth's crust and we are not finding water. And because of our uh, misuse and abuse of water, uh, drinking water is itself is becoming a problem. In such cases, we need to contain, reduce the usage of water in concrete construction, concrete production, as well as curing. So scientists have already looked into self-curing concrete, where mm, you have additives uh, in countries like US. They have started using super absorbent polymers, where they absorb water, be in the concrete, and start giving the water as the concrete ages, and helps hydration to go continuously. So even in India, developments have taken place. Some of the companies have come with very novel additives which can help in self-curing. About 1% you have to add, and then uh, just probably one day initial curing is sufficient for such kind of concretes. Integrally added concrete can be mixed, and this self-curing admixtures are compatible with other admixtures, and you can use this not only in concrete but for mortars, plasters, any of the concrete, wherever cement and concrete is produced, wherever you feel that uh, curing water is not available, or we should not use more of water, wherever that situations are there in remote places where tall chimneys are there, or where you cannot reach. In all those places you can use this concrete, and especially columns actually, columns where curing is neglected many times, and intermittent curing is done. To avoid that, you can add this integrally and make this self-curing concrete. Precast special admixtures are
Sir, Kaushik sir, are you there? Audible uncle. Sir, Kaushik sir, you are not audible. Uh, the participant, sorry for the inconvenience. He will connect in a while. Just there is a power cut. He will connect immediately. Sir, Kaushik sir, you are in. Are you able to share the screen? No. Clear, it's fluctuating. Sir, can you hear me?
Yes.
Kaushik sir, is it audible? Yes, sir, you can share now. Yes, sir, continue.
Connection. There was a problem with the connection. Now it is okay.
No problem, sir. No problem, sir. It's okay.
Yes. Yes.
Just share your.
Can you hear me now? Hello.
Yeah, yes, sir. You're audible. It's clear. You can proceed, sir.
Okay. Okay. So I was talking about special admixtures which are found being used in precast concrete, where they have blended accelerators with high range water reducing admixtures. And there are other admixtures which are being produced, especially for precast industry, to control efflorescence. Hydration control admixtures are being used in other countries to control the rate of hydration and to control the heat buildup within the body of concrete, so that the thermal cracks are reduced. So I can say one of the most important steps that has been taken by one of the scientists, Dr. Heng Chenkers, is uh, to produce and give to the world what is called a self-healing concrete. There are different kinds of cracks, plastic state cracks and hardened state cracks, and both may cause durability issues if not attended. And most of the waterproofing systems give way over a period of time, leading to water penetration and penetration of other contaminants like chloride, sulfates, etc. No matter how carefully it is mixed or reinforced and then placed, all concrete eventually cracks, and under some conditions, those cracks can lead to collapse. So it is almost impossible today to ensure 100% crack-free concrete, both just after placing and during its service life. So cracks lead to leakage and eventually damage concrete structures. So all concrete, especially reinforced concrete, if have to survive the test of time against weathering agents, need to be crack-free and made impermeable. While somehow you can achieve impermeability, making crack-free concrete mortar is out of question. It's difficult. Dr. Hank Junkers worked on the concept of self-healing, and he started making what is called as biomimicry, imitating life like a wound on a living organism or a cut on our skin heals by natural process. So in 2006, he started working on special bacteria, and this bacteria has to um, live. Once it is produced, once it is introduced, it has to be alive in the body of concrete, which is very alkaline in nature. And the technology is that it will be dormant for time until water and oxygen enters into it. Actually means if it gets sufficient amount of oxygen and water, then it starts reacting. So the bioconcrete is mixed. just like regular concrete, but with an extra ingredient called healing agent. It remains intact during mixing, only dissolving and becoming active if the concrete cracks and water gets in. So Dr. Henjenkers chose Bacillus bacteria for the job because they thrive in alcoholic conditions. And to heal the cracks in the concrete, Jenkers chose Bacillus pseudoporous and B. coli. Dr. Henjenkers chose Bacillus bacteria for the job, and which can live without food and oxygen for several years. The next challenge was how we are going to put this into the concrete, how it can work in the concrete. So Dr. Henjenkers chose calcium lactate, setting the bacteria and calcium lactate into capsules made from biodegradable plastic. And when we add these capsules into the concrete during the mixing stage, it will be there in the concrete, and when the cracks develop, it will react, and then capsules will open, and bacteria will germinate and multiply and feed on the lactate. And while doing so, combine with calcium with carbonate ions to form calcite or limestone, which will close the cracks. Actually, this is the technology. Very uh, simple to say, difficult to make these capsules. I can say self-healing concrete has been tested in Netherlands by Dr. Henjenkers and one company Netherlands, and they have made already pilot studies and have done all durability studies, including how it heals the cracks and things like that. And they have specified about 5 to 10 kgs per cubic meter of concrete. This healing agent has to be used, and this is very, very important, especially in all structures which are meant for public transport, military applications, huge water retaining structures, where these cracks can, I can say, reduce the or deteriorate the concrete structure. So in those situations, which are of national importance, so these we need to have these kind of healing agents. As I said, the applications are in flyovers, bridges, metro, water storage tanks, nuclear power plants, defense infrastructure buildings, marine structures, tunnels, and all other concrete structures, wherever durability is of very top in importance. And Dr. Hank Junkers, through his studies, had indicated that these pores can be there in the concrete up to 200 years. And then, so virtually, the concrete structure can be maintenance free up to 200 years. So now, people have started using 3D concrete, making small structures with 3D concrete. 3D concrete is, as on today, it is 3D mortar. Actually, means it's a mortar which is put into situation where it is called as ink, and it is printed. It is printed, and I can say it is pumped to make the walls and then the roof slab. And in this situation, when you are making a 3D concrete, rather 3D mortar, the admixtures have to have give good pumpability. It should give shape stability. Once the first layer is deposited, when the next layer comes, the first layer should support the second layer, and it should give a thixotropic mix to avoid particle segregation, sag, and the addition between first layer to second layer should be good. There should be reduction in shrinkage because the cement contents are high, and it should initiate rapid strength development. So a lot of companies, a lot of work is being going on throughout the world in improving the performance of admixtures to make the admixtures suitable to produce best 3D concrete. A new class of additives have come into picture. A lot of studies have taken place. The materials are graphene oxide microfilm fillers Fibers, of course, fibers are there for a long time. Different categories of fibers: steel fibers, polyvinyl, alcohol-based fibers, polypropylene-based fibers, polyester-based fibers, natural fibers based on hemp. There is a multitude of fibers which are being used for different purposes, from mortars to ultra high performance concrete. Microphone fillers are popularly available in India. I can say in India, India is the first country probably to produce a fine GGBS powder, which is called as popularly known as Alcofine, which is used across India for making high strength concrete and high performance concrete. And similar materials are based on fly ash and other materials are being used. Whenever we are using these microfine fillers, we have to be aware of the fact that what is the value that it is adding to the existing concrete. What is that we want from this product? That is what we have to target actually and think about and select suitable microfine filler. So graphene oxide is one of the promising material. It is used at about 0.03%, and it is set to increase the compressive and tensile strength in the range of 15 to 25%. The big problem with this material at this moment in India, talking about, is the price is high, and we did some trials and the results are inconsistent. I mean, basically because the dispersion is difficult. We cannot disperse properly, and then it doesn't get mixed properly through. For example, you are talking about a very low dosage of 0.03% to get mixed in a big truck carrying 6 into 2.4 tons or 7 into 2.4 tons is not an easy job. So mixing method, price and dosage is problem at this stage. And hopefully in the future things will get sorted out. The other technology which is coming into picture is CNTs, carbon nanotubes. They get the name because of their cylindrical nature and nanometer diameter. And you have single wall carbon nanotubes, multi wall carbon nanotubes. They are significantly enhance mechanical and physical properties of material. Use of carbon nanotubes increases the strength and durability of cementitious composites, as well as pollution reduction. When researchers think of nanomaterials, reinforcements for concrete, carbon nanotubes come as the first option actually. It has been proved that there is a good interaction between CNTs and cement phases, indicating that potential for crack bridging and enhanced stress transfer. So the strength and flexibility of carbon nanotubes makes them potential use for controlling other nanoscale structures, which suggests they will have an important role in nanotechnology engineering. Again, challenges with this is price currently and dispersion, but multi-wall nanotubes have shown in many of the experiments good strength improvement, both compressive and structural strength improvement, abrasion resistance improvement, and all the properties, all the engineering properties, most of them have been reported as better. But as I said today, in the Indian market scenario, or many of the parts of the world, the price is a big question. So one of the products is a patented product, again, which we can say is a big shift in the concrete technology, because the product which you are talking about is a product which enhances durability, and it gives many benefits and shifts the concrete to the next level. It is a product which is blend of microminerals and which conforms to ASTM C1797, and it is not a superplasticizer. It acts by promoting dissolution of alumina and iron present in the supplementary cementitious metals. It accelerates the hydration, increase the rate of silicate reaction, forming additional binding pieces other than CSHL. And the materials which are produced will fill up the capillary pores and then reduces the pore size. Some of the examples we can see here. We talked about the water symmetry show law. This material is perhaps, I have not seen other material. I'm talking about this material law. This is one of the materials I can say at this moment, which is almost defying the water symmetry show law. You can see at 0.33 water cement ratio, 450 kg cement content, 50 MPa concrete, and at 400 kgs, when we reduce from 450 to 400, the water cement ratio goes up to 0.38, and you have the strength at similar to the control. We have OPC GGBS mix where we use this product at 2% concrete, and you have this original cement content 225, 220, 450. 100 kgs of cementitious contents total is reduced, giving similar strength. OPC PFA, again, 360 plus 90 has been reduced to 280 plus 7. So you have these mixes, better mixes with lesser OPC content, sometimes with higher fly ash or GGPS content, that is SCMs. And the other beauty of the product is it enhances the permeability, it enhances the impermeability, it enhances the durability. And so it is a product which is a all-rounder, which reduces the cement content, makes the economical mixes. On the other hand, you can increase the SCM contents. It reduces the shrinkage cracks. Many of the companies have started using in India this product for reducing the plastic stage cracks actually. Uh, and it is a impermeability enhancer, durability enhancer. So these are some of the additives and admixtures improvements that has happened in the last uh, 10 years or so. Uh, I'm sure 1 hour we cannot cover many of the other advancements. There are so many other products which I can say one of the technologies which is going to come into the market is how you can make 3D printing completely different, completely different. So means how there is a possibility of enhancing the concrete mixes with admixtures. So a lot of work is going on, but since we are short of time, I will stop at this stage. Uh, so any questions can be asked now, or any questions can be sent to me anytime. So I can answer. Thank you. Thanks once again to Dr. Sridevi, Madam, for inviting me to this lecture, and thanks to all the audience. Thanks to all concerned. Thank you. Any questions are there? You can ask.
Sir, there was a question and question answer session. You can see like Subramaniam sir, Dr. Subramaniam Narayan
Okay.
sir has asked the question. Is it visible to you, sir? You can
I'll
see
just.
Q&A.
I'll just.
Q&A.
Dr. Subramaniam sir, namaste. Good morning, sir. We can use two or three. Can we use two or three different admixtures in the same concrete? Yes, we can use any of the admixture, two, three admixtures together. In fact, earlier, before I can say around 2005 to 2010, 2005 to 2010, there were companies, including very world leaders like Master Builders Technologies. What they were doing is they try to give these type of that is superplasticizer separately and retarder separately. You use the superplasticizer at 0.6, use the retarder at 0.1. Together you push into the concrete, mix into the concrete, and then make the concrete. So two admixtures or three admixtures, like you have a superplasticizer, you have a SRA, and you have a integral waterproofing compound, or you can have a crystalline water proofing admixture. Like this, you can have whatever number of products you want to have. Only thing is, some of these combinations sometimes may cause retardation. For example, you have a type G admixture which is already having an inbuilt retarder, and you add a waterproofing material. Some of the crystalline waterproofing materials have have this property of giving a retardation. So if you put all these together, probably the setting time may be increased. Some of these waterproofing compounds also, based on lignosulfonate based admixtures or air entrainment admixtures, can affect the strength if the quantity is more and if the water reduction is not done. So those are the precautions. Means when you are combining two, three admixtures, you have to balance the water cement ratio. Do not you have and initial hardened properties of concrete. Uh, Another question from Dr. Subramaniam sir, Ramakrishna.
Our work in the field of concrete technology. Once again, thank you, Sir Kaushik sir, for your
Thank you, madam.
time, dedication, and accepting in spite of your busy schedule. And I also thank the audience for making this presentation and this lecture series a successful one. Thank you.
Thank you. Namaste, namaste, madam. Thanks a lot.
Namaste, sir.
Thank you.
Namaste.
Thank you. Thank you.
Good evening. Before we dive into our next main presentation, it's my pleasure to introduce the individual who will provide us with a glimpse into our speaker's impressive background. Please join me in welcoming Dr. V. Tirumurugan, Assistant Director Campus Life, SRM Institute of Science and Technology, Kattankulattur. Welcome, sir.
Good evening, everyone. Are you here? Good evening, everyone. Madam, are you here?
Hearable, sir. Hearable, sir.
Yes, it's audible, sir. Audible.
Good evening, everyone, and welcome to this Engineers Day Professional Talks event organized by ASC India Section Southern Region and the MTS India Section in association with Unnat Bharat Abhiyan SRM IST. On this special occasion, I extend my heartfelt wishes for the Happy Engineers Day to all of you. Now it is my distinct honor and a privilege to introduce distinguished speaker Dr. N. Subramanian. Dr. N. Subramanian hails from the beautiful state of Tamil Nadu and had his earlier education at the renowned Ramakrishna Mission Boys High School in Chennai. He had his civil engineering degree from Tyagaraja College of Engineering, Madurai in 1972 and his structural engineering degree from the College of Engineering, Guindy in 1974. Mr. Subramanian earned his PhD from the IIT Madras in 1978 under an international selection process. He was selected by the prestigious Alexander van Humboldt Foundation, Germany, to do postdoctoral research at the TU Berlin during 1980-82 and later at the TH Vandeswar Munchin in 1984. After returning from Germany, he successfully ran his own consulting and teaching institution, Computer Technology Institute, for over 25 years. Has designed over 600 projects of RC and steel structure and trained several students, many of whom are now working in USA. He did pioneering work on computer-aided design in the 1980s and developed a special purpose computer programming to run on PCs. Based on his experience and research, he wrote 25 books on computers, programming, and application on structural design. Notable books by him are Building Material Design, Design Reinforced Concrete Structure, Space Structure, Computer Genesis, Programming of Basics. In addition, he has contributed more than 315 papers published in international Indian journals and conferences, and is authoring a series of gems of structural engineering in the Journal of ISSE. His contribution have resulted in recognition like a Fellow of Indian National Academy of Engineering, Life Fellow of ASCE, Honor of Fellow of Structure, Best Book Award of ASCC India 2000, 2011 and 2013, ACC India Gaurav Award 2021, ICC L&T Lifetime Achievement Award 2013, Distinguished Alumnus Award CEG and Gindi 2015, Tamil Nadu Scientist Award 2001, etc. Dr. Subramanian took an active part in the several professional associations such as ASCE, ACI, ICE, ICI, ACCI, and the Rotary Club of Madras Metro. He served as a Vice President South and Indian Concrete Institute and the ACCE India and President of Rotary Club of Madras Metro. He is also serving on the editorial board of Journal ICI, International Journal of Space Structures, Indian Concrete Journal, CE and CR, and the review committee of Journal of ACI, ASCE, a practice periodical on structural design and construction and others. He is also engaged himself in several social and digital media linked in Telegram, WhatsApp, etc., and mentoring young engineers for the past 20 years. He is spending his time mentoring and educating young engineers through his books, talks, papers, and postings. Let's eagerly anticipate an enlightening and informative talk from Dr. Subramanian. Please join me in giving him a warm welcome as I share his valuable insights with us tonight. Thank you. Over to MC.
Thank you, sir. Now we have a moment of appreciation to share. Dr. V. Tirumurugan, sir, again, has graciously agreed to extend our felicitations to our esteemed speaker, Dr. N. Subramanian. Let's welcome Dr. V. Tirumurugan, sir, to express our gratitude to our speaker. Welcome, sir.
Sir, Dr. N. Subramanian, sir, it's over to you, sir.
Okay. Can I share my screen now?
Yes, sir. Yes, sir. Sure, sure.
So welcome you all. Happy Engineers Day. Of course, first of all, I would like to thank Dr. V. Tirumurugan for introducing me nicely. And then I would like to thank Engineer Pradeep Sivanathan, Assistant Professor of SRM Institute of Science and Technology, and President of ASC India Section Southern Region for inviting me to give this talk. And then I also thank Professor Rajayogan, Dr. Sridevi Guda, Dr. P. Kishore, and others. Welcome all of you. So after a very interesting talk by the other distinguished speaker, Kaushika, on variety of admixtures. Actually, he has covered so many things from the preliminary thing to the latest development. So after that, I am going to speak on a completely different topic. It is pre-qualified. I have I have I am going to present it in 3 topics: introduction to earthquakes, moment-resistant steel buildings, pre-qualified moment connections. Actually, in the introduction to earthquakes, I will skip quickly because all of you know, but I have included it only for the completeness sake. And then I will briefly talk about moment-resistant steel buildings, and then pre-qualified moment connections, which are introduced in the AASC code. So though we have explored space above ground extensively, I think we have landed in moon, and then recently India has sent its first solar mission, Aditya L1. It will stay approximately 1 million kilometers away from Earth. But we have not gone very deep into the ground. Russian geologists could drill only up to 12.262 kilometers deep hole, that is 9 inches hole, near Finland in 1970, and after 19 years, it was sealed when the temperature reached 180 degrees centigrade. In 2008, this depth has been surpassed by the 12.289 kilometer deep oil well in Qatar. Why? How the earthquakes are formed? So the first, it was developed by Alfred Wegener in 1912. So he developed a theory called plate tectonics, and it was validated only in the 1960s. According to him, the Earth has got 16 principal tectonic plates. The earlier theories assumed gradual shrinking, contraction, or gradual expansion of the globe, whereas plate tectonics is based on continental drift. The lithosphere is divided into 78 major tectonic plates and other 8 smaller plates. When they move, they dissipate heat. Actually, they are maintained by the dissipation of heat from the mantle. That is a source of energy for them. The lateral relative movement of plates may be 0 to 100 millimeter annually. So earthquakes occur when the two tectonic plates move against each other. As I told, there are 8 plates, so the big plates and 8 smaller plates, and when they move and then hit against one another, the earthquakes are occurring. The rocks break underground at the hypocenter, and there, that is the place where they move, and the earth starts to shake. Waves spread from epicenter, that is the point surface on the surface above hypocenter. If a quake occurs under the sea, it can cause tsunami. Actually, around 500,000 earthquakes occur each year. They are detectable with current instrumentation. About 100,000 of these can be felt. Actually, even human activities that can produce minor earthquake that are storage of large water behind a dam, injecting liquid under high pressure into wells, that is fracking, to extract natural gas, coal mining, or oil drilling. So average recurrence of earthquakes are earthquake of 3.7 to 4.6 every year, of magnitude 4.7 to 5.5 every 10 years. Earthquakes of 5.6 or larger every 100 years. According to US Geological Survey, since 1900, an average of 18 major earthquakes, magnitude 7 to 7.9, and one great earthquake every year. The earthquakes occur. You see that in India, near Himalayas, this is a great earthquake region, because the Himalayas, the two plates join at the Himalayas. And another great earthquake region is the west coast of America. Four earthquakes, magnitude 8, greater than 8, have occurred in the span of 53 years from 1897 to 1950. The January 2001 Bhuj earthquake was almost as large. So these are this picture shows the different places where the earthquake occurred.
Recording in progress.
3.1 earthquake, and this shows the magnitude 8.1 earthquake. So this is a very important slide. They show the Richter scale, which was developed by a Californian seismologist Charles F. Richter in the 1930s. It shows a picture of him. And one important thing you have to remember is that the scale 2 to 3 shows that from 2 to 3, it is 32 times the energy is released. So this shows the number of earthquakes per year. Number 2, scale 2 occurs 1,000 times, but most of it is not felt, and like that, only one per year. And I have shown some of the earthquakes of these magnitudes. Of course, 9, Alaska in 1954, and 2011 in Japan. And similarly, two important earthquakes, especially for our subject of pre-qualified connections, are the Kobe earthquake in 1995 and Northridge, California earthquake in 1994. And of course, this shows the energy equivalent released from the earthquake. Actually, earthquake of size 6.1 or so is equivalent to Hiroshima atomic bomb. That is equivalent to 56 million kg of equivalent explosive. The earthquake design philosophy, as per IS 1893, is minor and frequent earthquakes, no damage to the structure. Moderate earthquake, under moderate earthquakes, no significant structural damage, but there can be some non-structural damage. But major and infrequent earthquakes, there should not be any collapse. But you have to know that there can be some damage. Hence, this design is done for much smaller forces than actual seismic loads. Note that this approach is different from that adopted in the case of wind, dead load, live load, and other loads, where actual loads are considered in the design, whereas in the earthquake design practice as per IS 1893, we are considering only much smaller forces. Actually, why, how that much smaller forces are enough? It is because the following contributing factors will prevent the collapse: overstrength, redundancy, and ductility. That is shown in this picture. So let us go to the next section, that is moment resistant steel buildings. First moment resistant steel buildings is in USA. The steel moment frames have been in use for more than 100 years. The first example is Home Insurance Building in Chicago. This is a 10-story building. It was built in 1984 and has a height of 42 meters. So early moment connections were very cumbersome. It consists of heavy triangular gusset plates, angles, and rivets connecting built-up columns and beams. And later moment connections, I have shown two. One is riveted unstiffened seat angle connection. The other is welded unreinforced flange bolted web connection. This was used from 1970 to 1974. Actually, in 1980s, codes required special design, configuration, and detailing of MRF used in high seismic zones and designed as ductile moment resisting space frames. In 1988, UBC designated as a SMRF, that is special moment resisting frame, and assigned highest response reduction factor RW. The term special was adopted due to special criteria applied to design, and they were expected to provide superior performance. Welded unreinforced flange bolted web connection deemed to comply the standards. Later, strong column, big beam theory, panel zone shear strength, section compactness, and lateral bracing criteria were introduced. During 1970s, moment resisting connections were used at every beam column joint, providing great redundancy and distribution of lateral force resistance. But in 1980s, designs economized and expensive field welding minimized by using fewer bays of MRFs, having heavier beams and columns, resulting in less redundant structures with more concentrated lateral force resistance. Actually, as I initially told that the 1994 Northridge and 1995 Kobe earthquakes were very important for our talk. Actually, they showed, I showed you the previous connections used till 1994. So those connections resulted in brittle fracture of welded beam to column connections. You just see here, this is a beam. So when the beam